In this video, we're going to talk about the Pythagorean Theorem and its converse. And chances are you've already seen the Pythagorean Theorem at least one time in school. So what we want to make sure to do is we have to be able to have a triangle that has to be a right triangle. The Pythagorean Theorem does not work on any other kind. It can only work for right triangles. Now, the way that I want you to start labeling your triangles for what we're going to get into later as well is the angles, your vertices. I want you to start, or at least continue, to label them with capital letters. And we're going to label our sides from here on out with lowercase letters. And it's a very simple process. The lowercase letters should match the uppercase letters, but on the opposite side. So let me show you what that looks like. We're going to start with capital A. It's this angle right down here in the bottom right. Now, if you shoot directly across from it, its opposite side there is what we're going to label as little a. Okay? And then we're going to do the same thing for the other side. So big B is all the way up on top. His opposite side is down here, so this is little b. And then big C, our right angle, the side opposite that is right here. So that's how I want you to continue labeling your triangles. So, of course, we know that the Pythagorean theorem is a squared plus b squared equals c squared. And all it means is that we're going to take the squares of our two legs, and they should add up together to give us the square of the hypotenuse. So, just a quick example. We're going to take a look at this problem right down here. It's actually the hypotenuse that we're looking for, and this is what's also really important about the Pythagorean theorem. Whatever your C is has to be the hypotenuse. It cannot be anything else. A and B represent the legs of your triangle, and A and B can be in any order. That's okay, but you must have it equal to the hypotenuse being squared. So when you take a look down here in this picture, the side that's opposite your right angle, regardless of the letter choices that you have for your vertices, is always going to be the hypotenuse. So our x is going to be where the C is in the Pythagorean theorem. So when we set this up, we can start with 6 or 15. I'm going to start with 6 and just go in ascending order. So 6 squared plus 15 squared equals x squared. And so we're going to simplify. We're going to square these numbers out. We're going to get 36 plus 225 equals x squared. And now we're going to combine our like terms on the left, which is 261, and that's equal to x squared. Now, anytime you ever want to cancel out something being squared, its inverse, what will cancel it out, is a square root. So we're going to take the square root of both sides, and when we do that, we're going to have the square root of 261 equals x. So the x is all by itself because the square and the square root completely cancel. Now, for me, right now, we are actually using our calculators to give us 3 decimal approximations for these. So if I were to do that, right now I would have x being equal to 16.155, and this is completely acceptable, okay, for now. We're going to start to learn how to simplify these radicals, and I would love to start that process now. I will include an additional video if you want to see this broken down a little bit more. So the way to actually simplify this in a proper way is to break that 261 apart. So the way that you do that process is you want to try to think of the factors of 261, and if you don't know them off the top of your head, it's okay. Use your calculator to help you. Write them out. Whatever you need to do is okay. But what you want to do is come up with one of those factors being a perfect square. And what I mean by perfect square are numbers like the square root of 1, which is equal to 1, or the square root of 4, which is equal to 2, square root of 25, which is equal to 25. They're numbers that we know. So 1 and 4 and 25 are numbers that we call perfect squares. So I'm going to mess around with this. I'm going to see what numbers go into 261, and you're going to find out that 9 times 29, oops, is actually equal to 261. And the reason why I picked that is because I know what the value of this is. The square root of 9 is 3. So I'm going to replace that with 3. And I'm just going to bring down the root 29. And I'm going to just continue this process until I can't do anything with what's under the square root anymore. What I know about 29, though, is it's a prime number. The only thing I can break 29 down into is the square root of 1 times the square root of 29. And granted, I know what the square root of 1 is. It's 1. But anytime you multiply something by 1, it doesn't change anything. So it's not helpful. So what we're going to do is we're just going to say that this is our final answer. This is the simplified version of our 16.155 approximation. And this is actually how I'm going to leave our answers in this video from here on out. And we're going to learn how to do this on tests and quizzes as well as your homework. All right, so here's our next example. Again, we're given a right triangle, so I know that I can use the Pythagorean Theorem to solve for anything missing. So again, we want to find the side that's opposite the 90-degree angle, which in this case is 11, which means that has to be my C. It does not matter if x is A or 9 is A or vice versa, okay? So we're going to start getting this all set up. So I'm going to say 9 squared plus x squared equals 11 squared. And we're going to square any numbers that we can first. So we're going to get 81 plus x squared equals 121. Now we have to get x squared by itself. It's attached with an 81 by addition, which means we're going to do the additive inverse. We're going to subtract 81 from both sides to cancel that, just like so. And I'm left with x squared equals, let's see, is that 40? Yeah. All right, now of course we need to cancel the square again, so we're going to square root both sides, which means I'm going to have x equals root 40. Now of course we're going to go through that simplifying process again to see if there's any factors of 40 that are perfect squares. And I actually know that root 40 can be broken down into 4 and 10. And that's helpful because I know the value of this. The value of root 4 is 2. So this is going to become 2 root 10. Okay, so I'm going to see if I can do anything with the 10. Now the factors of 10 are 1 times 10, and there's also 2 times 5. And please keep in mind that if you get a 1, it's not helpful. It is a perfect square, but it doesn't help break anything down. So I look at 10. Is that a perfect square? No. What about 2? Nope. How about 5? No. So if your answer is no to all of the factors, then that is your final answer. 2 root 10 is it. So something that might help you along the way are recognizing certain side lengths being in a certain order. So we actually have something called Pythagorean triples. And what it does is if your side lengths happen to have these particular sides, 3, 4, 5, those 3 numbers, when 5 is the hypotenuse, will always make the Pythagorean theorem work. So if you ever want proof, just work it out. 3 squared plus 4 squared equals 5 squared. Other Pythagorean theorem triples that you can recognize are sides of 5, 12, and 13. Of course, 13 being the hypotenuse. And there's 8, 15, 17. And there's 7, 24, 25. These are the most common ones that you'll see. This one, though, the 3, 4, 5, is all over the place. I see it all the time in my other classes, too. So the way that you use these, for example, would be if you have a right triangle, okay, and let's say you know that this is your missing side, one of the other lengths is 8, and the hypotenuse is 17. Okay, look at your Pythagorean triples. It looks like it's going to match this one. Okay, so one of the sides, one of the legs is 8, the hypotenuse is 17, which means that x must be 15. So I didn't have to do any math. I just have to know that this is one of my Pythagorean triples and all those sides should match those numbers. So the next thing that we're going to take a look at is what's called the converse of the Pythagorean theorem. And it just actually says the very opposite. It says that if your sides happen to make the Pythagorean theorem work, then your triangle is a right triangle. And this is a very informal way of stating this theorem. You guys have the better definition on your theorems packet. So we're going to go straight ahead and see if this actually works. Now the longest side is going to be C, because it should be the hypotenuse if this really works. So we're just going to go ahead and set this up. So 6 squared plus 8 squared equals 10 squared. So what you're looking for is that the left-hand side matches the right-hand side. So we're going to square our numbers. 6 squared is 36. Oh, don't know what happened there. 36. And 8 squared is 64. 10 squared is 100. And sure enough, 36 and 64 is 100, which means that the triangle is a right triangle. So that's all the converse of the Pythagorean theorem says. So there's just one last thing that we want to look at, and it's called Pythagorean inequality theorems. And these are theorems that are in your theorems packet, which at this time is theorems 8.6, which is right here, and theorems 8.7. Okay, so you guys can add these in there. So basically, what this says is if we replace that equal sign with inequality signs, it can actually tell us what kind of triangle that we're going to have. So if a squared plus b squared is greater than c squared, you have an acute triangle. If it's less than c squared, then the triangle is obtuse. All right, so here's our last example. We're going to determine whether each set of numbers can be the measures of the sides of a triangle. If so, classify the triangle as acute, right, or obtuse. So before we can even do this Pythagorean inequality theorem, we have to see if we can actually make a triangle with this. And if you recall from way back when, we have to add 3 pairs of sides together to see if it's greater than the third side. So in other words, we have to do 7 plus 14, which should be greater than 16. We have to check if 14 and 16 is greater than 7, and then we have to see if 7 and 16 is greater than 14. If we don't do this process, then we're going into this problem assuming that we have a triangle, and we may not. So we have to do this first. And of course, as we look through this, 7 and 14 is 21, so this one works. 14 plus 16, that's obviously going to be greater than 7. And 7 plus 16, well, 16 is already greater than 14, so that's going to work as well. So once you know that you have a triangle formed, now we're going to use the Pythagorean inequality theorem to see what kind of triangle it is. So we're going to use the smaller of the two sides as the legs and the larger as the hypotenuse. So we're going to see 7 squared plus 14 squared is equal to 16 squared. We'll just check this one first, because if this one works, then our triangle is a right triangle. So this would give us 49 plus 196 equals 256. And I'm just going to check to make sure that that's true or not, and we get 245 on the left-hand side. So this is not a right triangle. Okay, what we can do now is see how those two sides compare. If I do 245 here and 256 here, how would we place the inequality sign? Which number is greater? And it looks like the 256 is going to be greater. So since our a squared plus b squared side is less than our c squared side, that means our triangle is obtuse, based on the theorem we just looked at. So that's everything that we're going to learn in this tutorial, and have a great day.